Hello everyone. So in this video we are going to look at one of the questions in which a student of mine had it out. So before going into the video I would like you to pause the video and look at the question and solve it and put your answers in the comment box and check whether the answer you got is going to match with the right answer. Okay. So the question says that a helicopter is rising from the ground and it was initially at rest, and the acceleration with which it is rising is g, and it reaches the height h. So at height h a packet is going to be released from the helicopter and it is going to reach the ground. So the question is, the time taken by the packet to reach the ground is what? So this is the question. So initially the helicopter is at rest, so my u will be 0 and the acceleration is going to be g and the distance it covers is height h. Now with all these parameters available, we will first find the final velocity of the helicopter at height h, which is found using this formula: v square is equal to u square plus 2a into s. So my final velocity will be root of 0 plus 2 into g into h. So final velocity of the helicopter at height h is root 2 gh. Since at height h the packet is going to be released, the initial velocity of my packet is going to be the same velocity as my final velocity of the helicopter at height h, right? The velocity will be transferred to the foot packet, right? So my initial velocity of the packet is going to be root 2 gh. Okay, now what all parameters do we know about the packet which is being released? We know the initial velocity, that is root 2 gh, and we know that it has to reach the ground which is at a height of h, and in this question we will consider the upward direction to be positive and downward direction to be negative. So the distance will be calculated as minus h, and we know that the acceleration will also be minus g. So with these parameters available, we need to find what is time. Okay. So what my student did was he used this formula: v is equal to u plus at, where we know the initial velocity now and we also know the acceleration, and time is the parameter which we need to find now. What about the final velocity? He considered that the final velocity will be 0 for the packet after it reaches the ground. Is this assumption right? Just because the foot packet reaches the ground, will the final velocity become 0? And in the question, they nowhere mentioned that my final velocity is 0. That the packet which is reaching the ground becomes rest. No, they did not mention it anywhere. So when you consider the foot packet reaching the ground, what is happening? So when the foot packet is going to reach the ground, it is going to collide with the ground, right? Because of this collision, it can even get bounced back, or it can, after hitting the ground, it can displace from its position. Anything can happen, right? And all the equations we consider here, v is equal to u plus at, s is equal to all this thing, v square minus u square is equal to 2as, all these equations consider only the acceleration as acceleration due to gravity, and because of this acceleration how my velocity changes. This is what we are finding, right? We nowhere thought about the collision which is happening between the packet and the ground. We are not including them anywhere. So it is not right for us to consider that this acceleration is making my final velocity to be 0, because they have not mentioned about it anywhere. So it is right away wrong to consider that my final velocity is 0. This is not right. So what can we do? How to find the time now? So to find the time taken by the packet, we can use this formula, which is s is equal to ut plus half at square. Now s will be minus h because we consider the downward direction to be negative, and u is going to be root 2 gh, and time is what we have to find now, and my acceleration will be minus g t square. So we are getting a quadratic equation, right? By solving this quadratic equation, we will get t to be 2 plus root 2 h by g. Comment whether you have got the same answer or not. Thank you for watching this video.